So in this episode, we're going to talk about the difference between sodium hydroxide and potassium hydroxide. We're going to talk about the substances that convert your oils into soap. Yes, coconut oil, olive oil, shea butter, beef tallow, castor oil. Those are all oily substances that can be easily converted into soap, which is basically something that cleanses. And the way they get converted is by using lye, like sodium hydroxide or potassium hydroxide. So let's get down and look at how these things work and what's the difference between sodium and potassium hydroxide. And if you're completely new here, my name is Perry. I have a background in chemical engineering and a master's in biotechnology, and I'm obsessed with understanding formulation and the why behind things. That's why I put together a free PDF that shows you how you can make 6 different skincare products with only 7 ingredients. If you want this free PDF, comment Perry, I want the system, and I will send to you. And this is to prove to you that you don't need 100 different ingredients to make soap or other skincare. You just need a handful of ingredients, understand their properties, tweak the ratios, and understand formulation in order to create many different products. And here's how soap making works. We have coconut oil, shea butter, olive oil. All of these oils contain triglycerides, which are substances that look like that. They have 3 fatty acid molecules bound together with a glycerin molecule. So for example, olive oil is a triglyceride of oleic acid. It has 3 oleic acid molecules bound together with a glycerol molecule. Coconut oil contains lauric and myristic acid, basically 3 lauric acid molecules bound together with glycerin. And then in order to convert coconut oil, olive oil into soap, you basically need a base. You need a very strong base. And the strong base can either be sodium hydroxide or potassium hydroxide. And when the strong base comes, like sodium hydroxide, the hydroxyl group of the base will basically attack the bond between the glycerin and the fatty acids. It will completely break the bond, and then you will get glycerin and soap. And basically this is very important because saponification leads to glycerin and soap. So glycerin is what's basically left in the soap to add moisturizing properties and to protect your skin from drying out, because glycerin is a humectant, it traps moisture into the skin. And then soap is what actually bubbles and creates a lot of lather. And this is the fascinating thing about soap making. Soap making is a transformation process. So when people tell me, Perry, if you make soap with coconut oil, doesn't that clog the drains or the pipes? No, it doesn't, because coconut oil converts to soap. So coconut oil contains lauric acid. When lauric acid reacts with sodium hydroxide, it creates sodium laurate. And actually sodium laurate is very water soluble and it bubbles a lot. And that's the fascinating thing about saponification. You get something that is oily and greasy, you mix it with a base like sodium hydroxide or potassium hydroxide, and suddenly you get something that bubbles and cleanses. So what's the actual difference between sodium and potassium hydroxide? Let's take a look. So the mechanism for both of them is exactly the same. They both create hydroxyl groups that basically attack the bond between the glycerin and the fatty acids and break it apart. So in both cases, you have the same hydroxyl group. But what happens here, in one case, you have a sodium atom. In the other case, you have a potassium atom, otherwise known as kalium. That's why it has the name K. And sodium has the name Na because of natrium. So sodium has a molecular weight of 23 and potassium has a molecular weight of 39. So sodium is smaller. So the fact that sodium is smaller, it means that the soap crystals are actually going to be very, very tight. And that's why sodium hydroxide creates a very solid and firm hard bar, while potassium hydroxide is very large, so the soap crystals will not form very well together, so they will create a more loose structure with each other. And because of that, potassium hydroxide leads to a softer type of soap, and it's what's used to make liquid soap. Basically, when oils react with sodium hydroxide, they create the sodium salts like sodium oolate and sodium laurate and so on, and those create very dense crystals. That's why you get this beautiful solid structure here. While potassium hydroxide basically creates these very loose crystals, and the crystals cannot basically pack as tightly, and there are large gaps between the crystals, and that's why you get a softer type of soap, which is what leads to a liquid soap. Crystals are basically also the reason why soaps that are very high in olive oil, like the Castile soap, the Aleppo soap, the Marseille soap, they all need, when they're made with a cold process technique, they need minimum 6 months of curing. And that's why if you try to use a soap that is made with 100% olive oil, cold process, after just 3 or 4 weeks, you will get a super slimy lather that melts in your hands. So basically, if you use a soap that is made with a high concentration of olive oil, cold process after 2-3 weeks, you will get this very slimy lather that literally melts in your hands, because the soap crystals didn't have enough time to form a very good structure. So you get this disordered slimy lather, and it's very disappointing because people ask me, oh, I made soap with 100% olive oil and it was not long lasting at all. I used it for 3 days and it literally melted in my hand. So you have to let it cure for minimum 6 months in order for the crystals to form and create a very ordered soap crystal structure. I hope you enjoyed this video, and remember to comment Perry, I want the system, if you want to see how you can make 6 different completely skincare products with only 7 ingredients. Thank you so much for watching, and I'll see you guys next time.